Ever pondered about the fabric of the universe, the intricate weave of space and time? Space and time. They're not just abstract concepts that float around in the world of theoretical physics. No, they're much more than that. They're fundamental aspects of our universe, part of the very framework that holds everything together. They're the canvas on which the universe paints its grand masterpiece. Picture this. You're standing in an open field, under a starlit sky. The vast expanse stretching out before you, the endless sky above you, that's space. It's the physical dimension in which we exist, move, and interact. It's the stage where all matter, energy, and even we play out our parts. Now imagine a river flowing steadily from its source to the sea. That's time. It's a constant, unending stream that carries events from the past through the present and into the future. It's the rhythm that beats in the heart of the universe, the tempo to which all existence dances. These two, space and time, are not separate entities. They're intimately interwoven into a four-dimensional tapestry called space-time, a concept we'll explore more in the upcoming scenes. Understanding space and time is not just a matter of scientific curiosity, it's crucial for technological advancements. Take GPS, for instance. It relies on understanding how time behaves differently in space compared to on Earth. Or consider the Large Hadron Collider, probing the smallest scales of space to unravel the secrets of the universe. The more we understand space and time, the more we can harness their properties, the more we can push the boundaries of what's possible. So, as we delve deeper into these concepts, remember, we're not just exploring abstract ideas, we're probing the very nature of reality itself. Now, we embark on a fascinating journey, unraveling the mysteries of space and time. Imagine space, not as an empty void, but as a vast, dynamic stage where the drama of the universe unfolds. Think of it as a boundless three-dimensional realm where everything we know exists. It's where galaxies, stars, planets, you and I, have our being. But what does it mean when we say something is three-dimensional? Well, dimensions refer to the measurable extent of a particular kind, such as length, width, and depth, which are the three dimensions we're most familiar with in our daily lives. These dimensions define the parameters of our physical reality. They give us a sense of direction, a way to navigate the world around us. In a one-dimensional space, there's only forward and backward. Add a second dimension, and we gain left and right. The third dimension introduces up and down, creating the voluminous world we inhabit. These dimensions shape our perception and understanding of space. But space isn't just a static backdrop. It's not a rigid box where everything just happens. In fact, it's quite the opposite. Space is dynamic, it's flexible. It can bend, stretch, and warp under the influence of mass and energy. This phenomenon is a fundamental aspect of Einstein's theory of general relativity, which redefined our understanding of gravity as the curvature of space caused by massive objects. So, when we talk about space, we aren't speaking of an infinite emptiness. Rather, we're referring to this grand stage, this three-dimensional theater, where the cosmic ballet of galaxies and stars takes place, where black holes distort the fabric of reality, and where light from distant stars takes years to reach our eyes. Space is the medium of our existence, the field of our actions, and the stage of our cosmic drama. It's the framework within which we understand our universe, our place in it, and our relationship with everything else that exists. So space is not merely emptiness, but the very canvas upon which reality is painted. Now consider time. Is it just a relentless march forward? Well, let's unravel this together. Time, as we know it, is a non-spatial continuum. It's not something you can touch or see, but it's always there, flowing, shaping our lives. It's like a silent symphony, orchestrating the events of the universe in a sequence that appears to be irreversible. Once a moment has passed, it's gone forever, or so it seems. But what actually is time? It's far more than just the ticking of a clock or the turning of a calendar page. Time is the very foundation upon which we sequence events. It's the invisible thread that links the past with the present and the future. It's the measure by which we compare durations, from the blink of an eye to the lifespan of a star. Yet time is not just about durations. It's also about rates of change. Think of the speed of a racing car or the growth of a tree. We quantify these changes in terms of time. We say a car is moving at 80 miles an hour, or a tree grows 2 feet a year. These measurements are meaningless without a concept of time. Time also shapes our perception of reality. It gives structure to our thoughts, our actions, and our memories. It allows us to plan for the future and recall the past. It's through time that we experience the flow of life itself. However, the nature of time is still a topic of profound debate among physicists and philosophers. Is time absolute, flowing uniformly throughout the universe? Or is it relative, changing with the observer's motion and gravity? These questions continue to stir our curiosity and ignite our imagination as we seek to understand the mysteries of the cosmos. So, time is not just about counting seconds or marking days. It's about sequencing events, comparing durations, and quantifying changes. It's about understanding our place in the universe and making sense of our existence. Time, then, is not just ticking seconds, but the rhythm that choreographs the dance of the universe. But what happens when space and time intertwine, creating a four-dimensional fabric known as space-time? Imagine space as a vast three-dimensional canvas, and time as a relentless artist, ceaselessly painting the events of the universe onto this vast expanse. Separately, they are intriguing concepts, but together they form the very foundation of our existence. This marriage of space and time is what we call space-time, a four-dimensional framework where three dimensions are of space: length, width, and height, and the fourth is of time. But it's not as simple as just adding time to space. In this union, space and time lose their individual identities and merge into a single, unified entity. Now, why does this matter? Well, it's central to the theory of relativity, a revolutionary concept proposed by Albert Einstein. In his theory, Einstein suggested that the force we perceive as gravity is actually the curvature of space-time caused by mass and energy. Massive objects like planets and stars warp the fabric of space-time around them, creating what we experience as a gravitational pull. Think of it like a trampoline. When you place a heavy ball in the center, it sinks, creating a curve. Now, if you were to roll a smaller ball around the edge, it would naturally move towards the heavier ball, not because of a mysterious force, but due to the curve in the trampoline. That's a simplified way to visualize how gravity works in our universe. This concept of space-time was truly revolutionary. It completely transformed our understanding of the universe, forcing us to reconsider not just where we are, but when we are. It showed us that the universe is not just a collection of objects moving through space, but a dynamic, interconnected web of space-time. So, space-time is not just a concept, but the very stage upon which the universe performs its cosmic ballet. As we delve deeper into the mysteries of space and time, we might wonder, what does it matter? Well, as it turns out, it matters quite a lot. Our understanding of space and time has far-reaching implications, and its practical applications are woven into the fabric of our daily lives. Take, for instance, the Global Positioning System, or GPS. This technology, which many of us use to navigate our way around the world, relies heavily on our understanding of space and time. Each GPS satellite carries an atomic clock that ticks away with incredible precision. By comparing the time signals from multiple satellites, your GPS receiver can calculate its precise location on Earth. Without our comprehension of how space and time interact, this technology simply would not work. But the impact of understanding space and time extends far beyond our smartphones. It shapes our perception of the universe and our place within it. By understanding that space is not a static stage, but a dynamic entity that bends and warps in response to mass and energy, we've unlocked a new understanding of gravity, planetary orbits, and the behavior of light. Similarly, our understanding of time as a dimension that moves forward, yet can also be affected by speed and gravity, has revolutionized our perception of reality. It's led us to concepts like time dilation, where time can appear to move slower for an object moving at high speeds or in a strong gravitational field. This is not just theoretical. It's been tested and confirmed with ultra-precise atomic clocks on jet planes. So why does it matter? It matters because understanding space and time pushes the boundaries of human knowledge. It drives innovation, fuels curiosity, and deepens our appreciation for the intricate and beautiful mechanisms of the universe. I encourage you then to continue exploring these fascinating concepts. Let them challenge your preconceptions, spark your curiosity, and inspire you to ask even bigger questions. In the grand theater of the universe, understanding space and time elevates us from spectators to active participants.